Hello, so we're back, and this time we have a nice laptop to repair. So this is a case where the laptop has a charging issue, it's not charging, and the customer is buying like 4 more batteries to test, and it's still not charging. So we have 5 batteries, so are 4 here plus one from inside of the laptop. Okay, let's see what the customer is saying. The customer is a computer shop, monitoring Dynabook Satellite Pro C50. i5, that's a decent laptop. Charging issue. When you plug in the charging light randomly turns on and off. Will not charge the battery. And also the customer said I also have some spare batteries. Could you check them? So yeah, we are not assuming the customer, the computer shop, it's a computer business, actually bought the batteries for this laptop. But it is very possible. Okay. So let's have a look. Let me plug a charger on this one. We have a round pin, small charger. Found it. Found it. So plug in the charger. Wait, I seen there like 4 amps. Yeah, and the voltage is getting dropped to 10 volts. Huh? And when I press the power button, actually the current is going down and the laptop is starting. So the laptop, it is working. Yeah, but the voltage gets dropped, so you can see. So actually plug in the charger. Let me unplug this. Plug in the charger, the voltage, check that, is getting dropped to 10 volts, and the current is max current. I mean, I put the limit 2 amps, but if I put 5, it will goes to 5. So who can tell me what is the issue? Hmm? Come on. Come on. If you are on this channel for a while, you know already what is the problem, right? I mean, let's be honest, can be 2 problems. Yeah, 2 problems. So you have to check the first MOSFET. That's all, the first one. And you have to check the MOSFET, high side MOSFET from the charging circuit. Yeah, so we have the same battery here like those. And it's a nice motherboard, right? Yeah, it is. We have the charging port here. So let's unplug the battery. And I want to check first the first MOSFET. And the first MOSFET is not here. You see the charging port? Where is the first MOSFET? On the other side of the board? Can be. Maybe it's under SSD. I think it's under SSD. Or it's a power supply. What is here? Let's check. Yeah, so the input circuit is here. So you have the charging port, which is going straight to the first MOSFET, second MOSFET, right? Yeah, let's check those 2 MOSFETs. So this one is the second one, and it's good. And this one is the first one, and it's good. Oh lol. So actually the first 2 MOSFETs are good. Now let's go to the charging circuit, which probably is here. Yeah. And on the charging circuit, we have the comeback MOSFET, which is this one probably. And we have the MOSFETs, they are charging the battery. This one is good. This one is good. And this one is good. Oh lord. What is this? This one is good. Okay, now I'm a little bit confused. So plug in the charger without the battery. Let's check the battery voltage. So actually we can check on the coil, right? Yeah. So on the coil we don't have voltage. What? So we have no voltage on the, means it's nothing shorted on the charging circuit. Okay, let's check the first two MOSFETs, yeah? So first two MOSFETs, here is the input, right? Yeah, 19.2, and on the gate we have 19.2. Okay, that's not good. Here is the middle of the MOSFETs, and here we have 4.8, 4.7. And again, it's not good. Here you have 19.2, 19.2. Okay, let's see what MOSFETs do we have. Yeah, it's better without the light. $3905. So both MOSFETs are the same. Yeah, both MOSFETs are the same, but one MOSFET has 19 volts on the gate, and the other MOSFET has like 4 volts, 5 volts on the gate. Let's check the gate. Gateway source. One second. So we have the gates here and here are connected together. The gateway ground is not short. The gateway source not short. One more time. Both MOSFETs are good. So plug in the charger, and obviously the gates are together. Here we have 4.7, and here we have 4.7, right? But the thing is, those are channel N MOSFETs. So we should have 25 volts on the gate. 25, not 4. So gateway source, we have 14 volts. Gateway source, we have 14, but we minus, yeah, and that's not good, yeah. So it should be like plus 6 volts, and we have minus 14. Yeah, okay. The fault is pretty straightforward. I believe it's a BQ chip fault here. Let's try to find the BQ chip. Yeah, it's here. Oh, check here. We have a nice BQ chip here. I will say, let's remove the BQ chip. We do have another one, brand new. Perfect, so we remove the BQ chip, the old one. And we should have another one here, brand new. This one, pin number 1 here, good. So what I will do, I will dip the chip inside of the rosin, just to avoid, trying to keep the board clean. Perfect. Let's solder the chip. Perfect, right? Yeah, it is. Now let's see. Let me cool down the board quickly. Let's see what it's doing. We are getting 25 volts on the gate. Perfect. Let me plug the charger. So plug in the charger. And it's doing the same thing like before. And on the gate we have, let's see. On the gate we have 4.7. I can't believe that's crazy. We replaced the chip for nothing. I can't believe. So the old BQ chip, let me save it, yeah? So this one is good. Well, we didn't lose anything because it took us like 2 minutes to replace that chip. So at least we know the BQ chip is not faulty. So why the reason we have like 4 volts on the gate? What is the reason? You know what? I start this repair, but no one asked. Sorry, but who's taking 30 milliamps? Huh? We are replacing chips and yeah, but who's taking 30 milliamps? And that's a good question. So let's stop replacing random components and try to focus on actually what we are seeing. Yeah, we are seeing 30 milliamps and I'm not happy with 30 milliamps. The battery is not plugged in. So why is the reason why this laptop is taking 30 milliamps? The board is still hot. Okay, I believe it's a wrong path. So the first place, you see you have a chip there. Probably this is related to the USB or the network. Doesn't matter. That's not important. The thing is, if I take the cable out, 10 milliamps are going out. Yeah, so we have 20 left. 20 left, we have one LED here. That means it's taking around 10, 15 milliamps. Then we are left with 10, 50 milliamps, which is taken by the EC chip. So this is a wrong path, actually, looking for the 30 milliamps. Now, there's nothing getting hot on this motherboard. I mean, the BQ chip, you can see, here is the BQ chip. You can see a slight heat signature. Then you have the EC chip a little bit. Then you have the 3.3 LDO, this one, but nothing major. So we have no idea what's wrong here. So we have to go around the BQ chip and check what's going on there. Let me open the data sheet of this chip. We have AC detect pin number 6. And we have 4.7 volts. Okay, that should be fine. Then we have AC DRV, which is pin number 4. This one. And here we have 19. Wait a second. One second. AC DRV. Where is the schematic? Yeah, this one. AC DRV should be 25, okay? But we have on the MOSFETs, we have like 4 volts or something like that. And on the chip pin, we have 19. We can see the gates are connected together using a resistor and it's going here to the chip, AC DRV, which is pin number, one more time, yeah? Pin number 4. Pin number 4. So pin number 4, 1, 2, 3, 4. This one, 19. Okay, let's go back to the MOSFETs. So the MOSFETs, And we have here, we have 4.7, and here we have 4.8. Huh? Wait a second. Okay, let's go back to the BQ chip. So pin number 4, check that, is going to a resistor. So pin number 4 is coming here. And after this resistor, we have exactly the same voltage. Okay, let me check online the MOSFETs, yeah? Something doesn't add up. DC. $3905. Lol, I was wrong. I was wrong. Someone said on the chat, sorry. You know what? Very simple. MOSFETs, if it's, you know, a number which is not rounded, like 5, yeah, 5 should be a channel N, but it's not. They're both channel Ps. You can see channel P here, you can see channel P here. So what was the issue? The issue probably, it was the BQ chip. So now if I plug the battery, what will happen? It will charge? That's my question. If I plug the battery, plug in the charger, we have steady orange light taking 30 milliamps. Yeah. Plus of the battery, we have 7.5. So it's not charging. And it's taking 3 amps. Okay, got it. So we fix exactly nothing. Nothing. Yeah. The power supply is clicking and the battery is disconnecting. It was looking such a, you know, a easy job on the beginning. Okay. That's fine. Let's check the MOSFETs, the first two MOSFETs. So basically, you cannot, you can't really count on the multimeter, yeah? So what I'm gonna do, I'm gonna come here, ensure the gate with the source. And the voltage is going slow. Okay, let me disconnect the battery. Unplug in the battery, good. Let's check one more time. So here you have 19 shorting with the gate, and the voltage is going down, but not too much, 18.8. Shorting to ground, lol. How? Check here, shorting with ground is taking like 2 amps without voltage on the gate. Wait, those are channel P, man. Yeah, but doesn't matter if they are channel P. Doesn't matter if it's channel P. You have no voltage on the gate compared with the source. Right? Yeah, must be, right? Must be. Channel P. Yeah. I'm pretty sure. Yeah. Now we have no voltage on the gate, yeah? Compare with source. Why I still have voltage here? Huh? The voltage is going down a little bit because we have a diode across the MOSFET. Right? We have a diode there. Oh, that sucks. We have an internal diode, which is from drain to source. Yeah, we have a diode inside of the MOSFET. Exactly on this direction. You know what I mean? Yeah. Okay, but the next one, wait, the next one should be more interesting. Okay, the next MOSFET is, if I'm shorting this, is going to 0. Lol, the MOSFETs are good. The MOSFETs are good. The MOSFETs are good. So what is not working is actually the charging circuit, that's all. Okay, let's go back to the charging circuit. I don't remember what was last time. We had that long job, 2-hour job. What was the issue? So it was taking a lot of current. Was a shorted MOSFET, but it's not the case here. Because with the battery disconnected, so the BK chip doesn't know the charging current, I have 0 volts. So it's not like a high side MOSFET, no. Let's go back to the BQ chip. Let's see. So I believe those SRP and SRN, I'm pretty sure those are the pins. Yeah, SRP and SRN, 10 milliohms. Okay. Which are 20 and pin number 19. Let's see. 15, 16, 17, 18, 19, and 20. 21 ohms. It's good. That sucks. Okay, let's see what we have here. Gate with source. Good. Then we have gate with source. 0 ohms. No, gate with source. Good. And then we have gate with source. Good. Okay, let's check the system current sensor, which is, what is it? Is here. ACP, ACN. ACP, ACN, pin number 1 and 2. So pin number 1 and 2. One and 2. 0 ohms. 0 ohms. And probably is this one, yeah. Is this one, this resistor. So this is on the main power rail, this one. Okay, you know what? Let's check the capacitor around the BQC because on this moment everything looks fine. Good. 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 0 ohms. Do you think that capacitor is has to have 0 ohms? This one. This capacitor has 0 ohms. Probably, yeah. It's the current sensor. Ha ha ha. Yeah. It's the current sensor and it's going here. 10 ohms. And 10 ohms. You know what? I didn't know that. And this is the first time actually I'm finding out actually even the I knew that has a short circuit, MOSFET short circuit protection, but I didn't know actually also the inductor. So if you remove the inductor, yeah, and you replace it with a wire, it is possible to not charge or to not work. Okay, no more inductor replaced. Okay, you know what? I want to do something. Something interesting I want to do. So let me plug the charger. Good. And I want to check. Why we have 18.6 here? One second, why do I have 18.6 on this current sensor? So on the output of the second MOSFET, I have 19.2. But here, we have 18.6. What this MOSFET is doing here on my circuit? But one second. Oh, those are from the USB-C? Can be 19.2, 19.2, 19.2, and on the output we have 18.6. Wait a second. Okay, let's plug the USB-C. I'm confused. One second. So where the MOSFETs are going, the output of the MOSFETs? So from here, where is it going? It's going here. So what is here? It's a MOSFET. Wait a second. And this MOSFET is shorted. Check there, 1 ohm. You can see. Lol. So you understand? This laptop, it's unique. I never seen a laptop having 3 MOSFETs on the serial mode. So this is the 3rd MOSFET on the serial mode with the other 2. What can I say? I mean, we are learning. You know, the learning process, it will never stop. So you understand the thing. So the thing is, the output of the second MOSFET from here, yeah, the output is going straight to this MOSFET. 0 ohms, you can see. And this MOSFET, it is shorted. Okay, let's replace the MOSFET. I don't even know what MOSFET it is. Perfect. So we remove the MOSFET. I'm pretty sure it's shorted. Gone. Gone forever. Yeah. A036. Nah, I'm not trusting anything. A036 MOSFET. And it's a channel N MOSFET. Good, 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 good. Okay, let me grab a channel N MOSFET. My microscope died. Yeah, it's working now. It died again. What's wrong with my microscope? Okay, it's working. One day we should fix the microscope. Okay, so let me be straight. Yeah, this one is the old one. We don't need it. And the new MOSFET, which is this one, has to be here. The P number 1 there. Good, let's solder the MOSFET. Perfect, so the MOSFET is soldered in place. Okay, the MOSFET is replaced. Let me cool down the board. And hopefully it will work. But this is quite a unique case. I mean, I never seen like laptops with 3 MOSFETs. I've seen with 1 MOSFET and 1 diode, but not 3 MOSFETs. Let's see, plug in the charger. And remember what was the problem? The problem was the voltage was too low there. That's how we found, actually, wait, it's a shorted MOSFET. It's a dead MOSFET. Let's see the voltage now on the main power rail. And we have 19.2. You remember we had like 18 point something. Yeah. All good. Now let me plug the battery. Plug in the battery. Plug in the charger and we have the pre-charge current there. Check. 140 milliamps. We have the orange light there. And hopefully it will goes up. Hopefully. Let's check the voltage on the battery. 7.6. 7.6. And the battery has to have 8.7. Yeah. Yeah, you can see the current goes up. 870 milliamps. 870 milliamps. That's the charging current. Good. So it's fixed? Yeah, it is fixed. Yeah, that was the issue. But you know what? You know what? Just to understand, I checked every MOSFET, but not this one. Yeah. Perfect. So if we are powering up the laptop, the laptop is not coming on. That's cool. We killed the laptop. Why the laptop is not coming on when I'm pressing the power button? Oh, it is. 1.6 amps. It is. Yeah, it's working. Now we have the charging current and we have the current which is going to the laptop. Yes, loading the Windows. 2 amps. So everything is fine. Can we check if the voltage is going up? Yeah, we can. So check here on the battery. We have 8. You can see, and the voltage has to goes up. We have exactly 8 volts. and it's going slowly, it's going up. Yeah, slowly it's going up. We can check that on the current sensor. And yeah, we have 20 millivolts across the current sensor, so it is charging. Now, what do I want to check? I want to check the other customer batteries. I'm pretty sure they are all good, but let's check them. So plug in the charger, and the battery charging fine. Yeah, pre-charge current, low current. We can hold the battery a little bit. Yeah, 2.6 amps. And 870 milliamps. You can see it's the same charging current. So this battery is good also. Good. Now let me unplug this battery. This battery is good. The next one. Plug in the battery. And it's taking 110 milliamps. Let's charge the battery. The battery is taking 2.6 amps. It means the battery is good. But check the voltage on the other side. It's like 7.4. The voltage is very low. Let's see. Yeah, it's still on the pre-charge current, you can see. Let's charge the battery a little bit more. Let's see. Still pre-charge current. You know what I think happened here? Probably the customer or the computer shop, they try every battery. But obviously, the laptop was pushing full current into the battery. And on that moment, the battery electronic board, it will disconnect the battery. And it will not reactivate the battery till the moment you plug the battery on a laptop which is charging fine. And on that moment, the battery it will reactivate. So that's how the battery works. If I'm shorting a battery, the BQ power management chip will cut the power down. And the power until comes back when you plug the battery on a working laptop and you plug the charger. On that moment, the battery it will be active again. Let's see. Yeah, and it's charging. You can see 790 milliamps. So even this one is good. Let's see this one. This one straight away 890 milliamps. So this battery is quite okay. Well, this one is good also. And this one. And this one is good. It's charging with 890 milliamps. You can see. So all batteries are fine. Good. So the laptop is charging fine. Everything is working fine. Now, is anything to learn from this video? You know how long is the video? It's 1 hour. 1 hour video. I can't believe I spent 1 hour for a basic thing like, you know, shorted MOSFET. I can't believe I replaced the BQ chip for nothing. I mean, why did I go straight to the BQ chip? Because there was no voltage on the gate. Okay, yeah. And I thought that the first two MOSFETs are channel N. Yeah, we should always check the MOSFETs on Google. Screws left out. Okay, so no screws here. Perfect. Pressing the power button. The LED of it is coming on. Yeah, we have the charging sign, everything is fine. Unplugging the charger. Yeah, we still, the battery got some charge. It's all good. And it is charging with 850 milliamps. Okay, all good. So I'm gonna stop now. I will say, you know, probably I'm getting older, because otherwise I cannot explain the chain of the mistakes I'm making. But yeah, see you on the next one. Bye.